As an organization grows, its infrastructure usually hits a physical breaking point. You either push basic shared web hosting past its limits, or you start hoarding physical computers in a lab, racking up tangled cables and power bills for every new project. A reliable migration depends on how the virtual machine integrates with your existing hardware and your technical payroll. Buyers are immediately hit with confusing acronyms like KVM, OpenVZ, and Proxmox, stacked alongside drastically different pricing tiers that offer no clear guidance on which to choose. Choosing a VPS is a three-layered decision. You start by choosing the virtualization technology running your server. Next, you decide where it lives, in a cloud data center or deployed locally. Finally, you evaluate the operational cost of a managed or unmanaged setup. Most teams ignore that final operational layer entirely, focusing only on gigabytes of RAM and processor speeds. If these three layers aren't aligned to your budget and your staff, you risk paying for redundant management services or deploying a system your team isn't equipped to secure. The foundational layer of any VPS is the hypervisor engine. Historically, providers favored a technology called OpenVZ because it was highly efficient, allowing them to cram as many virtual environments as possible onto a single physical server. This diagram shows how OpenVZ achieves that density. It relies on OS-level container virtualization, meaning every user shares a single host kernel. That shared architecture suffers from weak isolation boundaries. If a user runs a heavy database query, their container swells, instantly draining performance and memory from your environment. A shared kernel also expands the blast radius. If that host kernel crashes or gets compromised, every single container tied to it goes down with it. To solve this, modern infrastructure relies on full virtualization technology, specifically KVM, or kernel-based virtual machine, which uses hardware-level virtualization extensions. KVM provides a dedicated kernel for each virtual machine. You operate completely independent of the other users on the hardware. This structure guarantees strict resource allocation for your CPU and RAM. It physically eliminates the noisy neighbor risk. KVM requires slightly more computing overhead to run those dedicated kernels, but in exchange, you gain the freedom to run custom operating systems and specialized kernel modules. For modern production web applications, databases, and predictable performance scaling, strict kernel isolation makes KVM the mandatory baseline today. Once you establish KVM as your standard, you have to decide where that virtual machine physically lives. You can rent it in the cloud, or you can build it locally on site. In research labs and enterprise R&D departments, teams regularly hoard separate physical computers for every new web server or temporary project. This wastes office space and hardware budget. You can consolidate all those physical machines into a single high-powered virtual manager by deploying the Proxmox virtual environment locally. This technical diagram maps the network topology for an in-house setup. A central virtual manager PC routes connections through a switch to distribute private server space. This single machine hosts multiple isolated VPS environments, allowing researchers to work simultaneously without interfering with each other. The primary advantage of this on-premise route is financial. You secure dedicated server space indefinitely, completely bypassing recurring monthly cloud subscription fees. You do accept clear trade-offs. You must pay upfront capital for robust hardware, like a Core i7 processor and heavy RAM, provide a physically cooled space, and manually configure your LAN routing. An on-premise Proxmox lab proves highly cost-effective for internal R&D if you already have the physical square footage and network infrastructure to support it locally. The final, and most frequently overlooked, layer of VPS architecture is the human cost. Someone has to actually maintain the server once it is deployed. The default option is an unmanaged VPS. You get total root access to the server, and you pay a significantly lower monthly financial rate. This flowchart isolates the critical question: do you have dedicated operations coverage, like a DevOps engineer? If the answer is no, unmanaged hosting presents a severe risk. Your team is entirely responsible for applying security patches and pushing OS updates, which pulls developers away from writing code. In that scenario, you should opt for a managed VPS. You pay a higher premium, and the hosting provider handles server maintenance, uptime monitoring, and security patching for you. Paying this premium is a necessary insurance policy for teams without IT staff. Conversely, if you already have a tech team on payroll, avoid managed hosting. There is no reason to duplicate costs by paying a provider for expertise you already employ. Paying for managed hosting wastes capital if you have an IT team, but serves as a vital operational lifeline if you don't. There is no universal best VPS. The correct choice depends entirely on matching the physical infrastructure to the reality of your team's budget and technical skill. This scorecard maps those 3 architectural layers into concrete profiles, starting with the academic or R&D lab. The academic and R&D lab fits the on-premise Proxmox model perfectly. These organizations can leverage their existing local area networks to solve physical server hoarding, securing multiple distinct environments without incurring monthly cloud subscription fees. Next is the modern SaaS team with a dedicated DevOps payroll. They require cloud-based unmanaged KVM. This stack gives them the strict kernel isolation and custom flexibility required for heavy web applications, and they avoid paying a provider redundant management fees for work their DevOps engineers already do. Finally, the solo developer or small business without an IT team relies on cloud-based managed KVM. Small businesses must trade money to save time. By paying for a managed service, locking firmly into a modern KVM architecture, developers can focus solely on writing code while avoiding the shared kernel risks of legacy OpenVZ setups. Don't buy infrastructure based on technical specifications alone. Buy the architecture that your team is actually equipped to support.